Hang on.
Well, good afternoon, everybody, and welcome to today's webinar for Smart Vision Europe. Today, we're talking about creating your own custom chatbot. That means developing a RAG solution using IBM WatsonX.ai. My name's Jarlath Quinn. I'm joined today by my colleague John McConnell, who's going to be taking us. We're both going to be taking you through our experiences and our learnings around this area. Just a few FAQs. If you haven't joined in these sessions before, you should be aware that we do record them. So you'll be able to listen to it again afterwards. And there is some slideware here. So you'll be able to download that material when we send out a link to you after the session's ended. If it's relevant for colleagues who are unable to attend, it may be possible for us to arrange a rerun of the session. The best thing to do is just drop us an email or something like that and ask us, and we'll see if we can fit that in. And with regard to asking questions, well, all the lines are muted. So we ask you to use the chat panel in the Zoom application. If we run out of time, we will follow up with you afterwards. We are quite used to people sending us emails afterwards, and we're quite happy to answer those if questions occur to you after the session has ended and you think about how you might apply some of this stuff in your own work. If you don't know who Smart Vision are, we are Smart Vision Europe are in fact a technology company. We're a gold accredited partner to IBM, and we're also a partner to Predictive Solutions and Data Robot. And we specialized in statistics, data science, advanced analytics, and AI technologies. Though I should point out we also work with open source technologies such as R and Python. And we're a relatively small organization, but we're made up of a veteran team of individuals who have worked within the advanced analytics industry and the software technology industry with 15 to some cases 30 plus years of experience. And that means that we're used to applying these types of technologies and these types of applications across many different sectors, both the not-for-profit and the for-profit sectors, down through the decades, whether that be retail or healthcare or charity or housing or central government. Lots of different applications, lots of different sectors. And certainly what we're talking about here today, we think would probably apply across the majority of those sectors and has multiple applications within it. Okay, with that in mind, let's just talk about the agenda today. First thing we're going to do is talk about RAG, what we mean by RAG, or retrieval augmented generative AI, and what that means. And we're going to talk about our own little RAG project, which was called Chat SPSS, and but the background to that was how we developed it, and give you a quick demonstration of it. You'll be able to play with it yourself. It is freely available to anybody that's interested in using the software. We're also then going to talk about the elements of the RAG solution, some of the theoretical background and the technical background to how a RAG solution works. Before we then jump into the IBM Watson X.AI platform. And while we're working in there, we're going to be pointing out some of the controls and options that you have, how you can start off to build a really simple RAG solution yourself. And we're going to be looking at two aspects of that. One is called the prompt lab. That's one way to do it. And also the auto AI RAG, which is an automated way to build a RAG model. In fact, it builds many RAG models. And then at the end, I'm going to pass to my colleague, John, who's also online, to talk about how you can deploy a RAG model out into the real world so it's surfaced for other people to use and how we did that when we were working with Chat SPSS. So the first thing we want to do is talk about what is a RAG solution. What do we actually mean by it? Well, retrieval augmented generation, or generative AI, combines generative AI with a retrieval system, allowing a model to pull relevant facts and context from large databases or document collections before generating an answer. So the key here is that you point this generative AI type technology at a corpus of documents or data or databases in order for it to query them and generate an answer in the same way that one might use some of these commonly available open AI type chatbots out there like ChatGPT or Claude or Microsoft Copilot. And the one of the advantages to this is that because we're pointing it to what we call grounded documents, that means our own documents or our own data, and it helps reduce hallucinations. Hallucinations being where the AI system, by virtue of the fact that of how it works, tends to invent answers, tends to invent non-accurate answers to queries. It helps to reduce that because, of course, we have a lot more control over what data it's actually using to answer the question to begin with. Because normally it's our own collection of data or data that we have access to, and which we know is hopefully up to date and is verifiable and is accurate. And as such, because we're using a generative AI chatbot type approach, it makes it very easy to query really large collections of data like reports or system logs or research papers or product information or medical records or so forth with a single prompt rather than doing lots of individual searches, and thus improves the efficiency, accuracy, and transparency in what must be said is a secure setting. The security is a big aspect of RAG solutions where organizations really want to control who sees their data and to make sure that their data isn't exposed to the outside world, which it might be if they were using some of the more popular or openly available chatbot type solutions that we've already mentioned. So again, why build your own RAG? Just to zoom in on that. Well, first of all, one of the aspects of it is user control and compliance, making sure that the right people can access and ask these questions to begin with. Quality control that can be customized and measured. So making sure that only the relevant documents are added to it and giving you control over how the answers are comprised. Much easier to swap models and change parameters easily. So that means basically you got a lot of control over how you can tune the chatbot. You can change the different types of parameters, the verbosity of it, the accuracy limits of it, and give it lots of sort of prompting, what we call system prompting, where you can put a bit of guardrail around it and say, make sure that you do this and make sure you do that. Ensuring relevance and versioning using the most up-to-date data. And lastly, integration and automation within your own systems. You can surface it within your own internal system. So accuracy, compliance, making sure that things are current and giving people control, the control over it. These are kind of the watchwords around RAG solutions. Of course, they're often deployed against quite esoteric data sets, things which really aren't exposed to the wider world anyway. So they're really useful for that if that data isn't really available in the wider world, if it's internal policy documents or internal information that really isn't surfaced uh, openly for other tools to access, then it makes sense, of course, to develop your own RAG solution to begin with. So real world applications of RAG solutions, well, there's a lot of them. So things like customer support, powering chatbots, of course. We've seen examples of this when we interact with commercial organizations, hopefully providing context-rich, accurate responses, retrieving information from FAQs and product guides and support tickets. In healthcare and life sciences, it could be anything, could be researchers querying medical literature, patient records, or data without sifting through loads and loads of unstructured text that's often out there in the form of emails, in the form of records, in the form of papers. Legal and compliance, helping lawyers and compliance officers finding relevant case law, regulations, trying to find exceptions to rules. That's a very important aspect, asking it to summarize or to spot unusual cases or any sort of issues around contractual clauses. In financial world, retrieving and summarizing current patterns, changes in the market, giving up-to-date information about policies or reports about sector behavior, about organizational or commercial company behavior. E-commerce and retail, enhancing product recommendation systems or answering customer questions using information drawn from product catalogs and reviews. And if you've got a big corpus of inventory out there, with a lot of information associated with user manuals, product catalogs, reviews, product information, then this could be a really good way for you to interface with that corpus of data and make sure that you're able to bring it all together in one spot and just use a simple chatbot type interface to query it. And lastly, government policy, allowing policymakers and analysts to extract relevant insights from large archives of policy documents or laws and public records. So I think, there's obviously tons and tons of different applications out there. These are just the typical, most obvious ones. But whether it is internal data that is quite esoteric and specific to the organization, or whether it's, islands of information that's publicly available and semi-publicly available, there may well be an application here that would be perfect for a RAG solution. So when we're talking through how we develop a RAG solution, you are going to see mention of certain technical terms that are going to come up, and we thought we should take a little bit of time just to talk about the elements that you're going to encounter when you start trying to develop your own RAG solution. One of the things you'll see is mention of an embedding model. Now, to a certain extent, you don't need to worry about this too much because, as you'll see, when you start building your own RAG solution, particularly if you're using things like Watson X, um, it'll select a lot of this stuff by default anyway. You can go and change them later on, and often people are doing this on the basis of experimentation or doing a bit of research around the difference between one embedding model and another. But suffice to say that what an embedding model does is that instead of storing raw text, let's say it's a document collection, the embedding model converts documents and paragraphs and sections and chapters and sentences into what it calls vectors. And these are numerical representations. They're basically fields. They're individual fields. They're numerical fields. And it's converting them into effectively a kind of coordinate system. And it creates from that coordinate system what's called a vector database. So the embedding model creates a database called a vector database. So after the embedding model has converted everything into this sort of numerical language, if you like, these series of vectors, they're stored in a database instead of the plain text. And you can think of a vector as kind of like a GPS coordinate in meaning space. Instead of longitude, latitude, it's hundreds of numbers that describe a semantic position of a text fragment. What it's really doing is it's telling you, for example, what words and what concepts and what topics appear close to one another. So a word like king or queen or royal or royalty, these are semantically linked to one another. So it knows that these snippets and these bits of text, what we call the tokens, are are linked to one another and that they exist within this what we say, this meaning space in a way that makes it easier for us to then pull out relevant data when we query or search for a particular term or ask about a particular concept. And to do that, we have something called a retriever. The retriever acts as a kind of research engine. The retriever takes the user query. So you might say something like, I don't know, I want to tell me what changes have happened in case law around this particular area in the past 12 months. It will take that query, it finds the best matches in the database, effectively, it searches the vector database, and then passes the set of snippets, text snippets that it's got, along with the user's question to an LLM, a large language model. This is what we read about a lot when we're seeing stuff in the media about AI systems like ChatGPT. And the role of the large language model is really to take these snippets along with the query and integrate them into its own reasoning to generate a natural language response. So it's the thing which then takes the data that the retriever has managed to grab from the vector database and then assembles it back into a way that makes sense to us. It actually authors it and creates a series of bullet points or sentences and appears as if somebody has just spoken to you, has written it in real time in front of you. In fact, what it's doing is it's basically predicting what word happens next. And in many ways, you can think of large language models as kind of word prediction tools. But in fact, in the most basic way, that's what's happening. We can think of this as the embedding model being the thing that creates the coordinate system, given that there could be more than one type of coordinate system that one could come up with. The vector database is effectively the map, and the LLM acts like a GPS. It's creating a route through the vector database to assemble a meaningful response to us. If we were to break down a single query, we would be saying, "Oh, here's a user question. That goes to the retriever. The retriever takes that query. It then queries the vector database. The vector database finds the relevant information, the bits of snippets of text within that vector database, then passes the question, the original question, and the retrieved text to the large language model, given that you could have more than one large language model, and then that gives you an answer. And one of the reasons we're pointing this out is because each of these elements can be optimized, can be changed, can be altered. There are different settings, different parameters. There's more than one large language model. There's more than one embedding model. There are different settings you have for the retriever that you can play around with. So these are all available to you when you're working, for example, within WatsonX.ai and you're building your own RAG solution. Okay. So before we get into that and we show you how to do that, let's just start at the end point and talk about our own RAG solution internally, which we kind of tongue in cheek called Chat SPSS. And the background of Chat SPSS was we wanted to learn about WatsonX.ai internally and kind of have a project to experiment with. And we wanted to learn particularly about the RAG capabilities of that particular platform. So we picked the test area where we already had a lot of subject matter expertise, which is the SPSS technology stack. And we obviously had some available data about that to act as an example and as an example that we could show people, and as a demonstrator that we could actually demonstrate to people and say, look, here's an example of a RAG solution that we've built. And we decided that if it went well, we might as well just deploy it out to the wider community of SPSS users. So we'd make it available to everybody if they wanted to play around with it or to use it as a tool, assuming they're working with the SPSS platform. Okay, so before we do that, well, how did we get there? Well, to build the Chat SPSS application or the RAG solution, we needed some data. And the data we started with was all of the different SPSS guides and manuals which are out there and freely available for people to download. So with each version of SPSS, you will have a number of different technical documents that relate to different aspects of the software. It's a modular software, so that means that there are specific elements that people can optionally add on. So there's a manual for decision trees, for example. There's a manual for complex sampling. There's a manual for advanced statistics. And there's a bunch of manuals that look at the basic operation of SPSS, what we call the base, as well as stuff about syntax, about algorithms, about administering it, about installing it and licensing it on different platforms, and they're available in different languages. So we thought, well, let's just take a bunch of them and see if we can build a little RAG solution which would allow us to query this corpus of data around SPSS so that we can ask it questions about, well, how do I do this and how do I do that, and what's the difference between this type of statistical test and this other type of statistical test. And we started out with 20 PDF documents. One of the reasons we started with 20 PDF documents is by default, if you want to build a simple RAG solution in WatsonX.ai, it only allows you to upload 20 docs or 20 different files, if you like. So these happen to be PDF. They could have been a range of different document types, but they happen to be PDF, and PDF is fine for us to work with. So that's what we did. And we created this little application called Chat SPSS, which I'll just jump out to and show you now. So I've got running here in the background somewhere. Let's see if I can find it. So here's Chat SPSS. This is now our version 3 of this. We've done various iterations of it, and I could ask a question. So I've got some questions here which I'll just copy and paste in. So let's see if I said, how can I recode a variable called region into a numeric version? So if I just copy and paste that in the chat SPSS. Here it is. You can see it's a conversation that we're having here. And it goes off and queries the document collection that we have. You can see down here we've got the conversation, and here is the response. It says, here are the steps to recode a string variable into a numeric version in IBM SPSS statistics. It also gives me some syntax here which I could play with. And it looks pretty good. It's telling me what documents it actually queried for that. It queried the core system user guide and the SPSS command syntax document. I could interact with this and say, how about an example for a string variable about social class, let's say. Let's see if this works. Social class. Let's see if it picks that up. So it says, oh yeah, okay, if you wanted to do it with a string variable called social class, it comes up with a little example of what that would look like. You got lower, middle, upper. And so this is the LLM is basically taking this query, finding snippets or the relevant information within the database, the vector database, and then inventing an example for me based on the social class suggestion I'd given it. Oh, and it's come up with lower, middle, and upper, for example, here. If I wanted to ask a completely different question, I could go and say, okay, I want to ask a different question now, start a different conversation, and just copy and paste that out. And I say, okay, well, let's say how can I generate 100 random records that show follow a normal distribution or something like that. In this case, I could ask the document collection. It might do that, but given if I'm really interested in syntax, and I say I really want to know this as a syntax question, so I want to see the SPSS code for that, we've actually got our own specific syntax model for that. The reason why we've got that is we've discovered that there are limitations with all of these tools. And if you're asking about syntax commands which have a lot of options associated with them, what we call a big syntax map, it is likely to get it wrong. It's likely to try and predict what the next sub command would be. And if it's a really complicated one, it may get it wrong. So we ended up building a specific model just for syntax itself, and then adding that to our chat GPT. So this is our version 3 of it. But this one looks correct. This looks like it's actually coming up some syntax that we could play here with. It says, okay, yeah, here's a looping command that you could add in, etc., etc. So we could continue to play with this, and we could ask it about the differences between one type of technique or another, jumping back and forth and starting a new conversation each time. We've got some controls here, whether or not it's in kind of a dark format or a white background format. We can export it as PDF. We've got a little feedback button here where people can ask people to give us feedback and comments about it. And links to privacy if they want to know about whether or not the privacy controls around this application. You can see that the one I'm working here with is our development. So this is our dev. We've actually got a dev and a production version of it. So we can test things out in our dev platform and then make it production. But in essence, this is how we're surfacing our RAG solution. So given that, if you wanted to explore that in more detail and play around with it yourself, then the best thing to do is just go onto our website, and you'll see under services, you can register for chatspss.com. It's entirely free, and play around with it yourself and test it out for yourself. So the next question is, how did we actually do that? How did we get to the stage whereby we built that little chat bot that references this particular corpus of documents? And we used WatsonX.ai, which is the IBM data science and AI platform, to do so. And we used something called Prompt Lab. So I'm just going to jump out to that platform for you to begin with. So here I am here. If I just go back, you'll see that if I log into WatsonX.ai as I am here, I can have a number of different projects. Some of these projects could be, data science type projects using things like the modeler application. They could be text mining projects. They could be stuff that's related to classification of documents, etc. We've got one here, but we started out in our little SPSS RAG project. If I click on that, It'll jump to that and it will show me some information about that with some tabs across the top here. The assets bit is a bit I want to go to. The assets shows the elements that are in the project. So we have things like data connections. We have things like the data itself. The data assets are, of course, the PDF files that we've got here. So you can see I've uploaded a bunch of PDF files. You also see a bunch of JSON files. I'll talk about that in a bit more detail. That relates to not to the next section, but the section after that where we get it to automatically build models for us. And there's a bunch of other different aspects. We can create connections to databases, for example. We've got something called a Milvus connection here. That's because when we build models, we can build them in memory or we can build them in database. If you want to build something that's scalable, really, and you're going to surface in the outside world, you probably want to use a database. But if you just want to play around with it and just get started and experiment, then by all means, you don't have to set up a database connection. You can play around with just the in-memory default options as I'm going to do here. So I'm going to actually start off building a vector database. I'm going to click on New Asset here, and I'm just going to find what the databases I'm going to work with. I'm going to start with a generative AI vectorized documents. That's just, you can see it's recent, but there's other things here you can do. You can build machine learning or RAG solutions automatically, build agentic AI applications. Have you heard about agentic AI applications? If I click on this set here, it says, okay, look, find some data for me to base this on. If I just come back here, so this is where we are. A good place to start if you want to play around with us, creating and testing a basic RAG model. What we're going to do is we're going to go to Prompt Lab after this. I'm going to show you this. And Prompt Lab is where we can design, test, and refine prompts against a library of IBM hosted foundation models. Those are LLMs, or even tuned models you've already deployed. And we can use it to experiment across models and different applications like summarization, question and answering, extraction, classification tasks. And you can try out different prompts, compare outputs, and lock in effective settings without writing code. So that's what we're heading towards here. So the first thing I'm going to do is just define a name for this particular vector database. I'm going to call it webinar example. You can see here under advanced settings, there's the different embedding models we have available. I'm just going to go for the default. So you could experiment with this. We have things like chunking. You can see this. So immediately we have stuff about chunking. This really relates to the retriever and the bit embedding. So chunking breaks large pieces of text into smaller, semantically related segments or chunks, and it improves the retrieval of relevant data. It means that it's much more sensitive and precise. And we also have things like a degree of overlap between them, so we can control the degree to which overlap. Because obviously, you don't want to you don't want to break off a chunk and find that you're actually halfway through a relevant paragraph. So it always overlaps to a degree with that. But these are kind of parameters that one could play around with at this stage if you wanted to. So we've got webinar example here. This is one of the ones we're going to create. It's here. I'm going to say select from project. If I want to find some data here. So here are all my uploaded PDF files. So I'm going to say I just want to pick a few of them. I'm going to pick the statistics core system, the brief guide, and the base system here. Select that, and I'll just give it a name. As I say, I'll call it webinar example, and then hit create. And immediately what it's doing is it's grabbing those three PDFs and it's creating it's creating a vector database in the background where it's effectively turning them all into vectors, turning them all into numerical measures, which effectively act as a coordinate space, hopefully linking together or creating a coordinate space for all of the concepts that are linked together. That takes me to the next stage, and immediately we have some controls here, which we can play around with. So we have the settings about the embedding models. We have search settings here, which relate to the retriever. So research, if I click on edit search settings here, it's saying what's the top K? Well, top K is the number of search results to sample. It determines the exact number of most similar items or nearest neighbors to retrieve in response to a query. So it'll find three potential chunks, if you like, or three potential sources, and then it ranks them and says, okay, this is probably the best source of data for that at that stage. Again, even at this stage, we can play around with this, and we have some sample questions that we can add. I'm actually going to add some sample questions here. So, sample questions are quite useful if you want to play around with different types of models, different types of settings within the prompt lab itself. So, I'm just going to go out here to my Word document, and I'm going to paste in some sample questions here, so I can reuse them on a regular basis. So, I've got one here called "What does automatic recode do?" That's added a sample question. I've got another one saying, how can I read data for tables from an external database? I'll paste that in as a sample question just to test it out. And the third one is, what's the difference between two different types of correlation? So Pearson's correlation and Spearman's correlation. And we can test how various models within the prompt lab answer this. So at this stage, I can now click on this subtle little button down here that says Open Prompt Lab, and you'll see that these questions are all sample questions are already there, ready for me to play around with, and I can choose different models. Well, I think the default model is this is actually it's about to be depreciated in next month, but it's an IBM LLM. It's called the Granite model. It's made of 8 billion different components to it, 8 billion different coefficients, if you like, and I could choose a question like, what does automatic recode do? And it goes and queries that model. And it gives me a response and it tells me what document it took that from. There are only three documents here, so we can play around with this at this stage. So we have a bunch of different RAGs models we can play with here. You should point out that over on the side here, this isn't just necessarily just for RAG. You can actually have a bunch of other types of applications. So we've got things like meeting transcript summaries, we've got scenario classifications, we've got feedback classifications, claim processing, fact extraction, code generation, translation of English to French. These are little templates, if you like, or little examples that you could use as if you were trying to develop other types of applications, not necessarily just RAG-based applications, because Prompt Lab isn't just used for RAG-based applications. So we're happy with what we're working with here. If we wanted to look at these other models that we have available to us, we can click on View All Foundation Models. And here's a bunch of different models. You can click on one of them, like, let's see, this Llama model here. It gives me information about that. It tells me how it was constructed. It's a non-IBM model governed by a third-party license. You could choose that. Or you could choose something like Llama Maverick. I tend to use Maverick quite a lot. It's one of my more one of the ones I find that work quite well with the SPSS documentation. At this stage, it immediately jumps back to just the default sample questions. So I need to click on the grounding with documents again. Grounding mean using these documents. It's a webinar example. And then say, what does automatic recode do? And it goes off and runs automatic recode. You can see the response is quite different from previously. Now it's giving me very nice clean bullet points. That tends to work quite well. Let's test that. Let's compare and contrast that to another model. I've got one here called Mistral. It's a small Mistral model. Let's again try that and see what that looks like against it. So what does automatic recode do? Again, it's bullet pointing it. It's given me an example use case there, which the previous one didn't do, which is really quite useful, quite interesting to know about. What would happen if I asked it a question that isn't related to the documents in here? So if I say, okay, look, I don't think there's information in any of these documents about decision trees, such as the CRT decision tree. If I paste that in, oh, sorry, I haven't copied and pasted it properly. So let me just see if I can copy it. What's CRT decision tree? It says I cannot answer that question based upon the provided document. So it's not, we know that's not going to the outside world. It's not going querying the outside world. It's only using the documents. You might find, for example, if you use a different one like Maverick here, that it might try and have a guess at that. It depends on the model itself because there might be a mention of other types of tree in there if I click that. It says it can't answer it. So I've found in the past that sometimes it might have a go with it. You should bear in mind that in the nature of chatbots, there is a random element to it. There's always a random, these are probabilistic. So if I hit regenerate this response, it might not give me the same response each time, and you can play around with that. If I chose again this clear the chat here, and if I chose again this webinar example and said what does automatic recode do for the Maverick model I chose there earlier on, you can see here it is. It's giving me some use cases. One of the things I can control is I can control what's called the system prompt. The system prompt is the instruction that the LLM has, and most of this system prompt here is about telling it to behave itself, not to give any harmful or racist or sexist or toxic answers, which is a possibility with large language models. And there's also a lot of control here over the formatting of that. Well, I could actually give it a bit more context. I could say, look, I've got a system prompt here which I can copy and paste in and say, look, you're actually an SPSS RAG system, and you know, you should try and answer the questions in the following way. So I could actually paste that in there. Some of it repeats what's already been said about not being sexist or not being racist, things like that. But I've said things like, don't answer queries using Python or other coding languages. It's a possibility it could do that. I've noticed that in the past. So I put that instruction in. I've asked it to be concise. I've asked it to try and give an example wherever it can, maybe in syntax or something like that, and hit save at that point. So if I go back here and say, again, using my grounded vector database and say, what does automatic recode do? It gives me this answer. Let me just see if that's the Lava Maverick. Am I using the right one? Yeah, okay. So yeah, that's okay. So it's giving me a very similar answer to the last time. It's just say you can't control the degree of randomness in it. Let me just try it again. See, sometimes it might give you a response. Yeah, so now you see it's giving me it's a slightly different answer because this is in the nature of these types of systems. This time it's actually given me an example with syntax in this occasion. There are controls here. I'm not going to go into all the model parameters here, but there are things that one can control here. So for example, one takes the temperature here. It says what is sampling temperature. Higher values like zero point 0.8 will make the output more random because it's predictive in nature. It's trying to choose the next question. If you want it to pretty much produce the same sort of answer each time, then lower numbers, it'll be more consistent, it'll be much more conservative. But if we wanted to kind of stretch out a little bit, maybe try and look at other potential terms or words which might appear. If you wanted to have more control, if you wanted to stop it repeating itself, you got a frequency penalty. There's a possibility it might use the same sort of concept over again. You can play around with these and again test them out. These are very much experimental at this nature. And if I ask, what does automatic recode do again? Is it different this time? No, it's pretty similar. I found that when I've played with some of these, if you push that number up high enough, it just starts to kick out just random information to you, really, really random characters, and not very useful at all. Now, at this stage, having played around with the different settings in this little tool that we have, the Prompt Lab tool, you could actually say, "Look, I'm happy with this. It's working quite well. I wish to deploy it," and you could deploy it at that stage. However, given the fact that there are many different parameters, and you only got a few questions here you're playing around with to try and test it with, you might want to be a little bit more thorough and maybe try to get it to try out different settings, different models in a more systematic way. And to do that, we have another approach. And the other approach is to use the Auto AI RAG. So Auto AI RAG is where we can set up what are called Auto AI experiments. And these are ways in which we can try out lots of parameter settings, so different embedding models, different chunking, different LLMs, different language models, and rank each of the different experiments or each of the resulting models in terms of how they performed. And one way to do this is to compare how each model scored against a perfect set of example questions and answers as part of an evaluation file. So rather than just giving a set of sample questions, we actually give it a set of sample questions and answers. And we say, okay, look, we're going to submit these questions and we're going to compare your answers to the kind of ideal or optimal answers. And then we're going to assess them and rank them in terms of how the degree to which they match those answers. So what you're going to see is when I run this, you're going to see actually not just one model that's been produced, but a number of different models. You can actually have up to 20 different models using a range of different LLMs, including the Granite LLM, the Maverick LLM, the Mistral LLM, and the Llama LLM that we saw earlier on, using different chunk sizes, different retrieval settings, and other parameters. And we're actually going to ask it to evaluate it against what's called an evaluation file. Now, in the version we were working with last year, because Watson X.ai is getting updated all the time, the way in which we did this was by submitting a file in the form of what's called a JSON file. Not as basically in this case, we can create a JSON file just by going into Notebook and typing out the questions and answers in there and then saving them as .json as a JSON file. The only issue is that they have a very particular format associated with them. So, they've got these parentheses, you've got these square brackets and curly brackets. The question is then asked in quotation marks, and then the correct answer is given, and you give it the correct answer ID. So I'm saying, like, when you import data and define a variable width string, what is the maximum width you're allowed to set? And I give an ideal answer, and I tell it where you can get that answer from. Now, that can be quite onerous for people to do, just going through and creating these questions and answers. So a way to get around it is if you don't want to write, if you don't want to kind of configure this file so it's exactly the same or it's perfectly formatted into a JSON file, you can basically write out a set of questions and answers and take it to another chatbot like ChatGPT or something like that, and which is what we ended up doing, and said basically take these questions and answers and format them using this example evaluation file, because it turns out that the system will actually give you a little sample evaluation file to show you the structure. And this is exactly what these types of AI chatbots are really good at. They're really good at formatting consistently files that are often fiddly in this nature. You could actually also upload a few documents to something like Copilot or Claude or ChatGPT and say, look, mine these documents, pick 20 good questions from them for me, explain to it what you want, what you're trying to do, and create a JSON file for me. And you could then delete or cherry pick the questions you want from that. So it isn't that onerous to create an evaluation file. Really, all we're trying to do is find a way to compare and contrast the different models that have been produced in terms of their accuracy or in terms of how well they match the correct answers that were given against these specific queries. And in fact, when it comes to evaluating the RAG model, it has three different metrics that it can use. One is answer faithfulness. This measures whether or not the generated answer is consistent with the provided retrieved context. It minimizes the likelihood, therefore, of the response including information that wasn't in the source documents, so hallucinations. Answer correctness is another metric you can ask it to optimize against. This evaluates the factual correctness of information presented in the final answer. And correctness verifies the answer against known facts in the documents and the evaluation file. And here the focus is on accuracy and reliability. And the last one is context correctness. This is a retrieval quality metric. In Auto AI RAG, context correctness is really testing how good a job the retriever does at pulling out the right chunks of context compared to the benchmarks. And as such, it evaluates the retriever, not the generated answer. So practical advice, if you want to minimize hallucinations, then you might want to optimize against answer faithfulness. If you want to match exact questions, such as in a safety and compliance application, you might want to optimize against answer correctness. And you can use context correctness to try and debug the retriever itself. So low scores here might indicate the parameters such as chunking, embedding, or retrieval may need tuning. Now, when we run the Auto AI experiment, what you're going to see is this. You're going to see it working its way through different steps where it reads the document collection, it reads the evaluation file that uses the JSON eval file. It starts processing the data, and then it starts to selecting a model, chunking it, doing embedding until it produces a model that you can then see and see how well it's, how accurate it is against this metric. And it keeps doing that, adding model after another. So here it's added another model at this stage. So let's just jump out and see a little example of that. If I just jump back here to the RAG project, this particular project we got in the background here, and I'm going to go down to experiment. And here's the all the way I experiments. I've actually got 16 experiments here. Here's one I did back in September. And you can see here that, oh, let's have a look at this. This was actually one I did earlier on today. This is the one I did in September. This has got 18 different models in it. So I can, I can optimize against this and say there's 18 different models in it. And down at the bottom here, I've got my RAG leaderboard. And I can see which one's the best one in terms of the thing that I was trying to optimize. Well, there's different optimizations. So here it's optimizing, I think, against answer faithfulness. So it's on answer faithfulness is optimized against. So this was getting a score of 93%. I could actually add in other metrics and say answer correctness at this stage and context correctness. And you can see it's doing worse on answer correctness and context correctness. So I could actually look at them all together. I could look at the pattern comparison here, and it says, look, here's all 18 of them. I can say, look, this one's good on answer correctness, 61%, pretty good on context correctness, 88%, and a little bit lower here on answer faithfulness, 84%. So we could choose one against the other, so we can compare them all. Or alternatively, we could say, oh, look, I'm gonna look at this one here. Let's just pick this one and say, what is that pattern for here? We can look at that. We go down into it and say, okay, it's sorted by order. Let's see if we can find pattern 4 and look inside it. And here, when we look inside it, it's giving me the scores for that one, and it's showing me the questions and the answers it is given and how it's scored against the 3 dimensions of accuracy, context correctness, and answer correctness. So I can look at these questions and the answers given and just sanity check it to make sure it's giving the right answers and questions, the right answers to the questions. Or I can compare patterns. If I click on pattern comparison, you could select another one here and say, well, okay, let's look at that against, I don't know, say this Maverick model down here and say compare pattern here. And we could compare one against the other, two models, two competing models at the same time, and just look at the answers they're giving. So, this one's given slightly more verbose answer. This one gives slightly shorter answers. We could check it that way. And thus we can compare one against the other. I usually find actually looking at, rather than looking at the metrics themselves, looking at the actual answers it's generating to the sample questions is a better way to choose a good model. And while we're doing that, we could actually say, well, look, that's pretty good, but I want to change this. I want to reconfigure the experiment. If I go to reconfigure the experiment, this is what I'd be doing right at the start. I can rerun it and I can start and say, okay, look, I want to run it in memory. I want to use a Milvus database. Well, in memory is fine. It says, what is your evaluation source? Well, I could have more than one RAG JSON file here to evaluate against. Notice that actually it's allowed you to generate questions and answers now with the LLM. I haven't found that to be very good at generating sensible questions and answers. It tends to ask questions like, what does IBM stand for? But it's also got a little template now that you can click on this button here and it'll open up a little template so you can add your own questions and answers. And you can automatically deploy the top ranking question. I wouldn't normally do that. But you can see this one's here, optimize against answer correctness. I can go into the experiment settings here and say, look, don't use all the models, just use a subset of them. And I can go, this is the embedding model here. So I can say, just use all, or try out all of them, or just use a subset of them, or whichever one I want to use. And I can go down to retrieval and generation here and I say, I want you to optimize against answer correctness or context correctness. This is what I want to choose the best model for. And I can go down here and say, I don't want to use all these LLMs here. I just want to try, say, Maverick and Mistral against one another. And I can go into the edit the system prompts here. And I can give it a system message prompt and a user message prompt. It's kind of like a global and a local prompt. So it's basically where I'm telling it it's an SPSS AI assistant and to make sure it gives examples and try to use syntax and don't use Python and that sort of stuff. And I can tell it how many patterns I want it to actually generate, how many different models. And then I can hit save and I can run that experiment. It'll run it in the background and start it off for me in the background. And the reason why that's useful is because you can then, if I come back to it here, you can actually say run that experiment. As it starts that process and running an experiment, I can actually look at different versions of it. So I've got different versions I've had running in the background in the past. So from one experiment, I can have different solutions and choose them. So this is how we can find an optimal model just by getting it to try out many different settings using an evaluation file and then judging it against a key criteria. And once we find a model that we like, let's say it's this one here, we can say save as, and we can save that model. We can save it away if we want to do so, or we can deploy it. We can actually deploy it as an AI service here, and we can send it to the deployment service to then be surfaced in the outside world. So those are two different ways in which we can generate models within watsonx AI RAG models. One is using simply playing around in a very interactive fashion using the prompt lab, which is the first thing I did. And the second is a much more mechanistic, much more sort of systematic way of doing it by using an evaluation file, which remember we can get another AI system to help us build and create, and then asking it to try out many different parameters, many different LLM models to select the best model and to compare one model's performance against the other before we actually deploy it. And on that note, I'm actually now going to hand over to my colleague John, who's going to talk us through deploying RAG models. And John, I will advance the slides when you ask me to do so.
Thank you, Jonathan. Um, One observation, which I'm sure many of you have made about what you've seen so far, is that we haven't seen much code. So I don't believe we've seen any Python yet. We've seen a little bit of JSON. So what we really like about the way that IBM allows us to build models in this way is that it very much kind of follows the SPSS ethos of what, in the modern day is called either low code or no code. So a lot of what we've done, most of what we've done so far has been done visually. When we get to deployment, we may break that. We may need to go to collaborate with some of it depends on, what our internal setup is, whether we're working with developers or IT or whoever it is. But in order to put something into operation, we probably do need to do a bit more coding. Although there are options that allow us to get quite a long way down the deployment path, which are still like low code and no code. So from the Watson side, we start off visually when we come to deployment, just as we were in everything that Java showed us so far. So broadly speaking, we got two ways of doing it. One is we can create a notebook, and that means a Python notebook. But this is automatically creating a kind of Python template which encapsulates the model, the winning model that we've just picked to decide to deploy. So the code is automatically generated for us. So we can hand that over to colleagues who can take that and implement that. So that's one start. And then the second style, could you go to the next slide, please, Jonathan? Is to deploy as an AI service where behind the scenes it's still a block of Python, but that sits within Watson IBM, within the IBM cloud, within watsonx itself. And it's something that we can make calls into from somewhere else, ask the questions to the chat SPSS engine behind the scenes and get results back. So in terms of how we deployed chat SPSS, we took this option. We took the AI service option. So once you've decided to go that way, you remember we've already decided which is the winning model. We've just specified that's the name there. We specified what we want to do, and we literally just hit the create and deploy option. If you could do the next slide, Jonathan. And that takes a little bit of time, but that creates essentially a package that wraps up the best model with the data that it created. Behind the scenes, we've created this vector database that Jala mentioned earlier on. We'll talk about the architecture shortly, but that sits inside a database called Milvus, and it essentially packages the whole thing up within the IBM cloud in a way that we can create an interface to it, a user interface to it that can be called and can give us the responses back. So if you could go to the next page, next slide. And literally, this is all about APIs. There's so much that goes on these days, which is about APIs because there's a lot of interoperability between different clouds, between different applications, and so on and so forth. So the IBM cloud creates an API, which means, we can carry on working within IBM, or we can take this API that's created, which allows us to have the conversation with the model that we've generated and deployed, and we can do it from wherever. We could do it from our desktops. We could do it from our public clouds, our private clouds, from our private servers, wherever it is, because the API is the interface to that. And literally, once the code is created, and we haven't seen much code so far, then we typically use one of those endpoints that you see in front of you, depending on how we want to make the deployment. So yeah, this slide shows how we've deployed Chat SPSS, and we've used a fair amount of code in here. We've gone a JavaScript direction, um, largely because we do a lot of JavaScript work. So we're using JavaScript libraries to create the user interface that Jala showed us. It's using very modern technology, so it works well on multiple devices, iPads, other tablets, smartphones, and so on and so forth. So we've used Java libraries that we talked about here that I won't go into great detail about them. But it doesn't have to be. You can create a user interface using Python. You could use C Sharp. You could use Ruby. There's so many different ways to do that. You could use tools that are not code-based, that are more visual to create a user interface. And again, do as much as you can without necessarily developing code. And equally here, what we've done is we've used Amazon. So we do a lot of work in Amazon, and we do a lot of work in the IBM cloud. If your tech team is more based on Azure or Google Cloud, or internal servers, Dockers, whatever it is, that's fine. It's all about building based upon the stack that you use in-house to make it available to your internal audience, and just letting the internal developers know what the API is that you created. We're using Linux here. You could use Windows. Again, we're using open source. There's so many different ways that you can configure this. Conscious of time, just to say very quickly, the way that it works is the SPSS users looking in the browser. It's all a secure connection to Chat SPSS, just as it would be to yours. The interface is all through the JavaScript. It's using these libraries in JavaScript, Quasar, D3 Express. And then whatever the prompt is that's created the question is fed through Node.js back through the API into the Watson cloud. And the hard work then happens between the model, which still sits on the IBM cloud, and the model talks to the vector database, which is a Milvus database, which just happens to be within the AWS cloud. Again, that could be anywhere. You don't have to use a Milvus database. There are lots of other options like Chroma. Your tech people might prefer to use a graph database. You might use Postgres. There's all sorts of different ways in which you can configure this. So Watson does the LLM questioning that we're very familiar with, but against our specific content, which is sitting within that Milvus database, gets the answers and then feeds that back, in the case of our example, chat SPSS, through Node.js, through the front end, and back to the SPSS user. So what you saw earlier is actually two of the big clouds working together. It's Amazon and IBM. It's still pretty quick and pretty efficient. And what it means is you can use the visual power of IBM to build your own business-driven RAG models without necessarily being a coder yourself. But then you can deploy it wherever you need to deploy it within your internal organization. And you may be an Azure site, you may be an IBM site, but whatever it is, it's interoperable, so we can chop and change. Back to you, John.
Okay, thanks, John. Just finishing up then, just so you're aware, then, of course, Smart Vision Europe, we have decades of experience providing guidance, training, and consultancy in the delivery of effective data science initiatives and AI initiatives like the one we've just talked about already. Um, with regard to working with Smart Vision Europe, if you're ready to start your retrieval augmented generation AI journey, your RAG journey, we can assist you with every aspect of your RAG project and help with solution design, technical architecture and ensuring the appropriate governance and security. And as experts in data science and AI, we will offer skills transfer consulting. So we'll help you develop the skills to do this yourself and collaborate with your own internal resources to deliver a complete solution that you will own yourself. And generally offer advice and guidance on engineering. The best thing to do is if you are interested in this, just drop us a line and we'll set up a call and talk to you about the options and the possible routes that you might take to address that particular type of application. Other services you should be aware that you can buy your analytical software from us often with discounts. We have our own web store where we provide access and people to purchase directly the IBM SPSS portfolio. And we also offer formal classroom, virtual training, and online self-training resources online. Generally speaking, we do offer no strings attached technical and business advice relating to analytics, and we also have tracked technical support services around the IBM SPSS product line. We do hope you found that useful. As I say, this recording will be available for you to listen back to again in the future. And by all means, if you do want to continue the conversation, we'd love to hear from you. Do feel free to reach out and contact us, and we'll be happy to talk to you. Thanks very much, and we look forward to logging in again in the near future.